Catching ships. This is the next bold milestone SpaceX must reach to unlock full rocket reusability, and the world is watching. The question is, when will it happen? Musk has offered new insight, revealing plans that may surprise some and spark debate with potential to significantly shape Starship's future. So, what exactly did he say and how could it change the program's path ahead? Let's dive in on today's episode of Find Out. Perhaps last year, many of us, myself included, truly believed that SpaceX would attempt its first Starship catching maneuver early this year. The anticipation remains as high as ever, but the reality has been more complicated than anyone hoped. In mid-May, Musk estimated that the first attempt to catch a Starship or ship could take place before the end of the year. This projection was later repeated during the company's discussion following Flight 9. At that point, there was still cautious optimism that the goal could be achieved within the 2025 calendar year. Now, however, that timeline is in question. In a recent interview with Tesla owners Silicon Valley, Musk did not commit to the same level of certainty. While he acknowledged that catching a ship before the year's end is still a possibility, his words carried more hesitation. Instead of a firm target, the phrasing shifted to maybe this year with a much more confident statement that the first half of next year is the most likely time frame. This shift in tone strongly suggests the first ship catch attempt may be delayed. The main reason lies in ongoing challenges from recent flights. Based on the outcomes of Flights 7, 8, and 9, SpaceX appears set to perform another ocean landing for the ship in Flight 10, avoiding a catch. Even the Super Heavy booster will not be caught, as key objectives from Flight 9 remain incomplete. If this plan holds, the earliest realistic chance to attempt catching both stages could be Flight 11, possibly between September and October. Hardware for that mission has already completed initial testing, and its status as the final version 2 Starship makes it a fitting candidate for higher-risk trials. However, this hinges entirely on Flight 10's success. Any failure would likely push the first catch attempt to Flight 12. The 12th flight test, however, is expected to debut Starship V3. SpaceX may avoid adding the risk of a ship catch to the maiden flight of a new design, as a failed attempt could undermine confidence in V3. Given the challenges V2 has faced, V3 will be a critical step toward proving operational reliability. If that's the case, neither of this year's remaining flights would be ideal for a first catch attempt, meaning the opportunity could slip to the second V3 mission early next year. Technical factors only add to this uncertainty. The ship faces a far more complex journey than the Super Heavy booster. While the booster returns soon after separation, the ship must complete a full orbit, enduring extreme temperature shifts and pressure changes in the vacuum of space. Its primary defense is the heat shield made of over 18,000 tiles. But this system has yet to meet SpaceX's standards. Previous flights have exposed weaknesses, and Musk has identified the heat shield as one of Starship's two biggest ongoing challenges. Engine reliability is another concern. Across the 3 Starship flights this year, engine issues have repeatedly caused failures during ascent, orbital operations, and re-entry. For a ship catch to succeed, engines must operate flawlessly. And the cornerstones of a flawless operation are launching to orbit, executing the return burn, navigating to the site, and synchronizing precisely with the chopstick arms. Other risks include fuel leaks, COPV malfunctions, and flap fires, any of which could threaten a safe return. Even with a perfect flight profile, the catch itself is high risk. Timing and positioning must be exact, as even the smallest error could damage the ship, the tower, or surrounding infrastructure. Another key factor is ground system readiness. Catching a ship will likely require 2 operational launch towers, as attempting both stages with only one would be extremely difficult. The current chopsticks at Pad 1 are designed primarily for catching the Super Heavy booster, not the ship. A specialized system for catching ships or potentially both stages is expected at Pad 2. Construction at the new pad has reached its basic structural stage, but installation work continues and no official testing has begun. At this pace, stable operation may not come until late in the year at the earliest. When considering the uncertain flight schedule, the V3 debut risk, and the technical readiness of both ship and ground systems, a ship catch attempt before the year's end appears far from certain. The outcome of Flight 10 will ultimately determine whether this milestone happens in 2025 or slips into 2026. So, what do you think? Can SpaceX make it happen this year, or will the wait continue? Indeed, the timing of SpaceX's first attempt to catch a Starship will have a significant impact on the company's long-term goals. This capability is not just another engineering milestone. It'll serve as the foundation for many of SpaceX's most ambitious future missions. One of the first major objectives that will depend on the skill is the construction of the orbital refilling system. Although SpaceX does not plan to reuse its Starship tankers in the early stages, the ability to perform a controlled landing using the most challenging recovery method will help optimize orbital launch operations. This efficiency is essential for building the infrastructure that will make refueling in space possible. According to Musk, the process of constructing this refilling system is scheduled to begin early next year. It's a crucial step that will pave the way for even greater missions, including delivering the Starship human landing system to the Moon and sending Starships toward Mars. By mastering the technique of catching a ship sooner rather than later, SpaceX will give itself more time to fine-tune this refueling system and prepare for these deep space objectives. From the second half of 2026 onward, SpaceX aims to begin a new chapter in its mission roster. Musk has stated that he is targeting November or December of next year for the first uncrewed mission to Mars. Around the same time, SpaceX is expected to carry out an uncrewed lunar landing demonstration. These precursor missions will set the stage for fully operational crewed flights. In all these scenarios, precision landing will be critical, and having mastered ship catching early would increase the likelihood of success. However, the importance of catching a ship goes beyond individual missions. This capability is a major step toward achieving full reusability, which will drastically reduce costs and accelerate the pace of launches. If humanity is to establish a sustained presence on the Moon or Mars, SpaceX will need to launch a large number of Starships in rapid succession. Building bases on another world would be an expensive endeavor, and minimizing costs through complete rocket reusability will be essential. Full reusability also sets Starship apart from its competitors. Most rockets in use today, such as NASA's Space Launch System, ULA's Vulcan, or China's Long March series, are still expendable. Yet the competitive landscape is changing. Blue Origin's New Glenn, Rocket Lab's Neutron, Stokespace's Nova, and several Chinese commercial rockets are all being developed with partial reusability in mind. These designs resemble the Falcon 9 approach, where only part of the vehicle is recovered. While these competitors remain far from matching Starship's capabilities, the gap could close over time. As the industry evolves, SpaceX must continue to lead by delivering breakthroughs that others have not yet achieved. Full reusability is not just a technical goal. It is the defining feature that could secure SpaceX's long-term leadership and competitiveness in the global space sector. Realizing these potentials, SpaceX has even more motivation to push forward with its ambitious efforts to catch the Starship upper stage. But before this bold milestone can be reached, the focus turns to Flight 10, a critical step in Starship's development and a mission that could greatly influence the program's trajectory. At present, final testing steps for both the booster and ship are still underway, with a launch target currently set for the end of August. These tests are not merely procedural. They are crucial opportunities for SpaceX to identify any flaws, large or small, that could jeopardize the mission. Every test run serves as a rehearsal for the real flight, allowing the engineers to catch potential weaknesses early and refine the systems before launch day. Among the many systems under scrutiny, the Raptor engine stands out as one of the most critical for ship. Engine performance is paramount in two distinctive phases. First, the engines must fire flawlessly at liftoff, propelling the massive rocket through Earth's atmosphere. Then once in space, the Raptor vacuum engines must ignite for key maneuvers, guiding the ship to its intended trajectory and preparing for payload deployment. Finally, they must restart again to assist in deceleration, navigation, and controlled landing. This is a demanding sequence, and history has shown it is far from trivial. On all three Starship flights this year, the upper stage has faced engine-related issues that cut missions short. SpaceX's response to these challenges has been swift. For instance, during preparations for Flight 10, Engineers identified an issue with the Raptor vacuum engine on S-37 and opted to replace it entirely. This proactive step signals the company's intent to leave nothing to chance when it comes to propulsion. Another persistent concern is leakage, an issue that plagues all space vehicles to some degree. Leaks can originate from the engines, fuel tanks, or various pressurization systems, and even small ones can prove catastrophic for Starship. Preventing leaks is not just about mission success, it's about ensuring safety and reliability for a vehicle designed for rapid reuse. Protecting sensitive systems on both S-37 and Booster 16 will be essential in withstanding the extreme stresses of launch, flight, and landing. B-16 in particular faces a grueling set of maneuvers during Flight 10. The booster will attempt a higher angle of attack return profile, an aggressive landing flip, and a touchdown using only 2 engines. Each of these tasks will push the limits of the vehicle's durability and stability. The booster's hot staging system, where the ship's engines ignite before stage separation, is another component under close watch, as it must operate flawlessly for the rest of the mission to proceed smoothly. Meanwhile, S-37 has its own series of demanding objectives. Beyond the mid-flight engine reignition, it must successfully deploy its payload, a step that has been hindered in the past by problems with the payload door. Resolving these mechanical issues is critical to the flight's success. Then comes one of the most punishing phases of any Starship mission: atmospheric re-entry. Here, the heat shield becomes the ship's primary line of defense against searing plasma and intense aerodynamic forces. SpaceX plans to experiment during Flight 10 by removing sections of the heat shield in specific areas and testing new tiled materials. While risky, these experiments are vital for developing a heat shield design that is both effective and easier to maintain between flights. Once through re-entry, S-37 will aim for a controlled landing in the ocean, a step short of a catch, but a necessary precursor to attempting one in future flights. These tasks form the core of SpaceX's goals for Flight 10. Even without a catch attempt, the mission is a critical milestone. Success would bring Starship closer to full rapid reusability.